This will be the video key for Module 3 homework. So we'll start with naming. And remember that you're always going to try to be finding the longest name. So this is 8, this is octane. We have a 3-methyl. We have a 5-methyl. And then at carbon 4, we have a 1,2 branch with a methyl at carbon 1, so that would be 1-methyl ethyl at 4. So it is technically an ethyl side chain, so it would be 4, 1-methyl ethyl three, 5 dimethyl nonane. So for this one, we have 1, 2, 3, 4, 5, 6. So we have a hexane. And we've got 4 methyl groups. We get a 3, a 3, and a 4, and a 4-methyl. So that would be 3, 3, 4, 4 tetramethyl hexane. So when you have more than one of the same group on the same carbon, they get the same number, and you also list that carbon twice. So make sure you do that. This one is a little bit tricky, so we could do 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So notice we have a branch here at carbon 2. That's the one that we want to do. So that means we have a 2-methyl, 3-methyl, 4-methyl, and that's a 3-ethyl. So the ethyl comes first. So this is 3-ethyl, 2, 3, 4. Trimethyl heptane. So resonance structures, here's where you have a negative charge on this oxygen, and then you've got pi bonds around the ring, so that's what we're going to be using. I'm not going to show the curved arrows this time, but we can take that negative charge and move it, so it's going to be like this. Maybe I'm going to show the arrows at least on here once. And then you can start moving the negative charge around the ring. So remember, when you're doing resonance structures, you need to follow the charge around. The charge is not going to go away. Oops. That's better. So those are the 3 resonance structures that you can draw, and you're just moving the double bond around once you get it into the ring. Draw all the possible Newman projections of the C2, C3 bond, so we're going down there. So as I did in class, I'm going to draw some templates. I'm going to do it quick so I don't make this video too long. So we're going to start with an eclipsed, staggered, eclipsed, staggered, eclipsed, staggered. So this will be 1, 2, 3, 4, 5, 6. And so on the front, I have 2 methyls and a hydrogen. And on the back, I have a methyl, an ethyl, and a hydrogen. So I'm just going to do my 2 methyls and keep them all consistent around the front carbon. Remember, I said multiple times that you don't have to do it the same way here, but I understand if you like the way that I do things and you want to mimic it, even if you think it's going to make me happy. So then Then we have the hydrogen, the methyl, and then the ethyl in the back. So hydrogen, methyl, and I'm just going to shorten this to ET. And so now we have hydrogen, methyl, ET. Going down here, hydrogen, methyl, ET, and then hydrogen, methyl, ET, and then hydrogen, methyl, ET. So now we want to think about which is the highest energy. So the highest energy is going to be one of the eclipse conformations. And if you look here, we've got two sets of large groups interacting. So 5 is going to be the highest. 5 is going, so if we look at number 1, we've got a ethyl hydrogen, methyl hydrogen, methyl methyl. And then we have a methyl ethyl. Well, that's immediately the highest energy. So then it's going to be number 3 and then number 1. Then we have, if we look at the stagger conformations, which one's the highest of these? Well, 4 and 6 all have the 4 alkyl groups with gauche interactions. But if you look at number 4, that ethyl group is in the middle, whereas in number 6, the ethyl is on the side, on the end. So that means that I'm going to put number 4, then number 6, and our lowest is going to be number 2. So this is a situation where I didn't make the highest one first. So number 1, 2, 3, 4, 5, 6, and number 1. So the highest is number 5. Then we've got number 3. Then we've got number 1. Then we've got number 4. And then number 6. And then number 2. So it's kind of like an up and down and up and down. And then we end back at number 1 again. So that's how you set that up. So for this one, so 2 of those, and then two of those. So 1,3 ethyl isopropyl. So that's both axial. And then I can go down here and then do a both equatorial. So ethyl up and isopropyl up. And then I have the two trans, so maybe I'll just keep the isopropyl here and make the ethyl group here down. And so ethyl down and isopropyl up. And we know that the highest energy conformer is going to be this one with both axial. And then the lowest is going to be the 2 equatorial. There's a circle. And then the two transforms where you have an axial and equatorial, and an axial and an equatorial are going to be in the middle. So if you want to think about 4, 1 ethyl, 3 iso, so all in number 4, make them with your model kit. So I won't include that in this video because I don't have my model kit with me. But hopefully you did it, and hopefully this will help. So I will upload this. If you have any questions, don't hesitate to ask.